Hi everyone, this is Professor Rosenthal, and in this segment we will study a topic called integration by parts. This is yet another technique of integration. So far we've learned, the main technique that we have learned is U-Substitution. So this will help us integrate a wider range of functions, things of the form, for instance, the integral of, let's say, x times sine x, because this is a problem that we cannot do with the techniques we've learned so far. Just using U-substitution would not be helpful here, but integration by parts will be able to solve a problem like that. So let's take a look, first of all, the derivation of the formula. This formula relies on the product rule. As you know, there is no product rule for integration. That's why it is difficult to integrate something of the form x times sine x, because we cannot go ahead and integrate the x separately and sine x separately. Right? There is no such rule. If there's a plus sign in the middle, yes, we can distribute the integral notation. With a product, we cannot. So in a sense, integration by parts is the closest we get to having some sort of a product rule for integration. Now let's begin by reviewing the product rule from differentiation, where we had learned that derivative of a product u times v, where u and v are both functions of x, equals u times derivative of v with respect to x plus v times derivative of u with respect to x. So remembering that, and the by parts formula will be basically based on that formula. What we do is we try to integrate both sides of that formula with respect to x. So what we're going to do is we will put integral sign on the left-hand side and on the right-hand side, and then try to integrate both sides. So I'm integrating both sides with respect to x. Therefore, note that I've also added a dx. So we're going to integrate both sides with respect to the x variable. And because there's a plus sign in between here, I can distribute my integral notation over the first term plus over the second term. So that's what I have done over here. So at this point, I can cancel, think of it as if these cancel in a way. And what you have is like you have the integral of the derivative of u times v. And we know integral and differentiation are inverse processes of each other. They're going to cancel. So over here, you're just going to have u times v. On the other hand, you have integral of u dv plus integral of v du. So basically we're almost there, but the typical integration by parts formula is stated a little bit differently. What we're going to do is we're going to solve for this quantity. So if you solve for an integral of u times dv, you would have to subtract this, right? You would have to subtract the integral of v du from both sides. So the integral of u dv equals uv minus integral of v du. And that's what you're going to see in the next formula, except that I put everything a little bit differently. So I put the integral of u dv on one side, and mine equals, like we noted over here, u times v minus the integral of v du. So this quantity equals this quantity minus that quantity. And I just rewrote it where this appears on the left and everything else appears on the right. So this is your integration by parts formula, and it is worth repeating because we're going to use it a lot in this section. So you would be expected to know this on the test. So the integral of u dv equals uv minus integral of v du. So the idea for these questions is anytime you have integral of a product, to try to make everything in the product be of the form u times dv. And if you can do that, and if from there we can actually solve for v, because we're going to need v over here, then that problem can be done with with integration by parts. But there's one more caveat, and that is this last integral, also we should be able to integrate that one. So you might say, what kind of formula is this? We're integrating something and we end up with another integral, right? Well, the idea here is we're going to end up with a much easier integral on the second iteration, and that's going to be helping us solve the original question. Okay, so let's take a look at a simple example, such as the integral of x times e to the x. So again, remember the formula, which is stated over here. So everything in our product here, we're going to try to write it on the form u times dv. So at the moment, let me let u be equal to x and dv be equal to e to the x dx. Okay, so typically we want u to be something that is easy to differentiate and dv something that is easy to integrate. And u usually usually, but there'll be exceptions. It will be the x or the power of x, because when you differentiate u, it will have a lower degree, right? Therefore, it will make things easier. The integral will become easier in the next iteration. It will take some practice, but usually u is the one that is easy to differentiate, and dv is the one that is easy to integrate. And as you differentiate u, typically we want to see it getting simpler and simpler. So in this case, for example, du is equal to 1 dx. And the idea here is from here to here, from u to du, notice we are differentiating our function. But going from dv to v, we're going to have to integrate or anti-differentiate. So if dv is e to the x, v is just e to the x. So now let's apply the formula. The formula says uv, so multiply these, uv, which is x times e to the x, minus integral of v du, minus integral of v du. So our v is e to the x, du is dx. And notice now that we are left with a much easier integral, simply the integral of e to the x, whereas we could not integrate the original integral, we certainly know how to integrate e to the x, right? So continuing on down here, the first term, we're going to just keep it as it is. And the integral of e to the x is e to the x. Don't forget the minus sign and the plus c at the end. We can leave it like that, or if you prefer, you can also take out an e to the x and leave us with x minus 1 plus c. Okay, so that's our first example, integration by parts. Now let's do a few more to get good practice, and you're going to see some of them are going to be trickier than others, but as with all sections we're covering, it always helps with lots of questions to get used to the method and to see all the different varieties, all the different tricks that can be thrown at you in these questions. Okay, so let's take a look at this one. Integral of 3x times e to the 5x. So I'm going to let u be equal to 3x and dv be equal to e to the 5x. Again, it's a very similar example. For the same rationale, I chose u and dv up there. That's why I'm choosing this quantity u and this quantity dv. Now, if I switched and if I made dv be 3x, then when I integrate, that's going to be 3x squared over 2. It looks like it's going to get more complicated, right? That's why I'm letting u be equal to 3x. Okay, so du is the derivative of 3x, which is 3 dx. And v is the antiderivative of e to the 5x, which is e to the 5x divided by 5. And remember, in differentiation, we multiply by that constant. In integration, we divide by that constant, right? And you can always use U-substitution to integrate that, but it's really not necessary. We should know how to do that without even U-sub. Okay, applying the same formula from above. So we're going to do u times v. So we're going to multiply these quantities. So u times v, which is, I'm going to put the 1 over 5 up front. So 1 over 5 times 3x times e to the 5x. Of course, I could have also written 3 over 5x e to the 5x. And then minus integral of v du. Minus the integral of, okay, over there, let me take out the 3 over 5. When they get multiplied, we're going to have a 3 over 5. Take it out. And here, the remaining, so v du, you're going to have 3 over 5 times e to the 5x dx. And now, all we have to do is integrate the last quantity. Once again, that's much easier than the problem that we start with. I'm going to write the first term as it is. Let me put it as 3 over 5x e to the 5x minus 3 over 5 times, okay, the integral of e to the 5x will be e to the 5x divided by 5 once again. And don't forget the plus c. So now I can combine those a little bit. So I'll have 3 over 5x e to the 5x minus 3 over 25 e to the 5x plus c. And once again, the alternate way to leave the answer would be to take out possibly a 3 over 5 e to the 5x from both terms. And let's also leave it in that format. So we can take out 3 over 5 e to the 5x. And that will leave us from the first term by simply x And from the second one, since we already took out 3 over 5, you only have 1 over 5 left here, right? And into the 5x was already taken out, so minus 1 over 5 plus c. A quick check, if I multiply this times that, I'll get the first term. If I multiply this times that, I'll have the second term. Okay, so let's take a look at one more example on integration by parts. And this time our example is to find the integral of x times cosine of 2x. Again, in the beginning for these questions, you can always try in your head, like to see, can this problem be done with U-substitution? You know, if I had cosine of x squared times x on the outside, that actually can be done with U-sub, right? You can let u be x squared and derivative is 2x dx, and that will be done with U-substitution. But x times cosine of 2x, that cannot be done with U-substitution. So for that, we're going to need to use integration by parts. So let's get started. Same technique that we used in the last two examples. So let everything here consisting of basically u and dv in this product. So once again, I'm going to let u be x and dv be cosine of 2x dx. And I need to find du, I need to find v. Going from u to du, we differentiate, so 1 dx. Going from dv to v, we anti-differentiate. The antiderivative of cosine of 2x. Okay, in differentiation, remember derivative of cosine is negative sign, and anti-differentiation is positive sign of 2x. In differentiation, you multiply by the 2. Integration, you're going to divide by the 2, by the constant. Okay, so now that we have our u and v, let's go back to the original question. The formula states we're going to do uv minus integral v du. That's what the integration by parts formula tells us, right? Integral u dv equals that quantity. So u times v, let's just write it down, is going to be 1 over 2 times x, or I'll just put that as x over 2 sine of 2x minus the integral of v du. So take that 1/2 outside, and inside we have simply sine of 2x dx. At this point, I'm going to rewrite the first part of this expression, x over 2 times sine of 2x. And over here I have minus 1 over 2, but when I integrate sine, first of all, integral of sine will be negative, right? So it'll be negative cosine of 2x. Once again, don't forget to divide by 2 plus c. And combining those two quantities together, I'm going to have plus 1/4 over there. So x over 2 times sine of 2x plus 1 over 4 cosine of 2x plus c. And that is our final answer for that question. So once again, we start with an expression that looks something like a product, and we write it with integration by parts formula. It appears to have another integral within the solution, but usually the integral is easier to evaluate, and with that we're able to solve the original question. Okay, this next example would be a great point for you to pause the video, try to solve it, and then I'm going to go through this very quickly, just pretty much show you the solution here, and then we're going to move on to different types of examples. All right, spoiler alert, I'm going to show you the solution, so I hope you had a chance to try that problem on your own first. And as you may have imagined, we're going to let u be equal to 7x and dv be equal to sine of 5x for this question. And derivative here will be 7 dx, and antiderivative here, remember antiderivative of sine. So here we're anti-differentiating, so it's going to be negative cosine of 5x over 5. And applying the formula, which is uv minus integral of v du. So u times v will be 7x times this quantity. So you can put all the constants up front as negative 7 over 5x multiplied by cosine 5x minus the integral of v du. So we're going to do integral of this quantity times that quantity minus the integral of v du over here. So there you're going to have, you can pull out the negative 7 over 5 outside and the integral of cosine of 5x. Okay. So if you take out the negative 7 over 5 outside, don't forget there's another negative here that will give us a positive 7 over 5 in the middle. And then you're still supposed to integrate cosine 5x. And remember that integral of cosine is positive sign. We're going to have sine 5x over 5, which will get multiplied with this 5, giving us a 25 in the denominator. So there is your answer there. And see you in the next segment to look at some different types of examples on integration by parts.